Hi everyone. For those of you who don't know me, my name's David Brown. I'm the co-founder of Nexthop. If you're an AusNOG frequent flyer, you might have seen me talk about fibre a few years ago. The network's doubled since then and it hasn't got any easier. I won't be talking about fibre today. I'll be talking about the IP side of our network, and for the point of my job title for that is actually the Director of Unscheduled Maintenance. I don't know how we come up with these terms, but they make me laugh every time. But before I move on, I'd actually like to talk about something pretty serious, which is sadly someone that we've lost since last AusNOG. I feel like they were there for my entire career, always there to answer my queries, and I don't think they really got the media coverage that they deserved in their passing. I am, of course, talking about routeviews.optus.net.au. It's sadly no longer with us. I'm sure it was a nationally significant funeral. We've got Gladys from Optus there, Prime Minister, and that guy top right, you're thinking, I know that guy from somewhere. He's the guy you've seen on every Cisco manual you've ever read. It's also been, thankfully, immortalised on none other than the AusNOG mailing list by Nathan Brookfield, who's given us a copy of the output. He's also demonstrated the key feature that's sadly missing from modern looking glasses, which is that you can telnet directly to it from your border router and run your queries and jump back in. And what's replaced it but the modern web-based looking glass? And we're all super original. We've all chosen the same software. And I thought I might try something a bit different. I might try some audience participation, and we really do appreciate everyone that does run a looking glass. It does make troubleshooting so much easier, and I thought we might just put our hands up if anyone here actually operates a looking glass and makes it available to your customers or the general public. Yeah, sure, whatever. NL ring, just something. Not that many, lots. Yeah, lots of you do, and we all thank you. Particularly the bigger networks, I'm sure it's really hard to get someone to want to, to do something like that doesn't really generate any revenue. And I have a second question, it's a bit more pointed, which is, how many of you actually make them available over IPv6? I mean, it's a bit of an own goal for me. I didn't actually know whether we did, and we don't. So, if you do, I've stolen one of my favourite ads, which is Telstra having a dig at Optus having a dig at Telstra, and I just love it when mum and dad fight in front of the kids. But I'm actually here to talk about monitoring systems, and as we all know, monitoring systems are a bit like safety regulations. They're kind of written in blood, and they're honed over many years based on real life events. And the systems that we run are nothing special. Top left, we run Observium. You might be running Libra and MS. These are great tools. They have two key features. They're plug and pray. You just point it at your router. It's going to tell you a lot of interesting stuff. It has a second feature, which is it will absolutely test the SNMP implementation of your router for memory leaks. It polls a lot of stuff that's just not normally polled. We're also running Zabbix. That's good for up-down alerts. It's also SNMP polling everything. Good for threshold monitoring and server monitoring and all that kind of thing. And finally, we have our flow monitoring system. For us, it's SFlow, which we run on Arista routers. And tying it all together is Netbox and Grafana. And we're actually, our Netbox is talking to third parties, and we have a curious link there between our Observium and our Netbox. And Grafana is a great visualizer. Before Netbox, there was just so many spreadsheets. Definitely IP addresses in the spreadsheet, and I kind of miss it in a way. And so we all go on this journey, and it probably starts with the IP addresses. And before you know it, we've got our routers in there. We know where our racks are, how they're wired up, and all that kind of stuff. And then at some point, we lose interest, or we kind of go, it's close enough. We're probably not going to go to putting all the IPs on everything, creating every sub interface, whatever. And so what we do is we have a mix of stuff that is source of truth, and we have stuff like routeviews.optus, which is just never going to be automated. and every config is handcrafted. And so we use the netbox scripts feature. If you haven't checked it out, you can basically point it to a directory of scripts. It will read them all in. If you create the right class structure, it will present them in a pretty nice and meaningful way. It'll record every script that's run, whether it was a success, who ran it, all that kind of thing. And what we do is we already have all of the data in Observium. So we've written a script that just syncs all of the IP data about a device into netbox. You also do the easy stuff like IP address and LOA generation. And if you have a data center that will actually give you details about your cross connects, what you should all do is get their inventory reports, access their API, and wash it against your cross connect data. Because so many of our LOAs that we issue are just blocked by people who never bother to cancel the cross connect. And I'd like to actually acknowledge that Equinix, in my opinion, is probably the best at this in terms of the data that they give their customers. I'd like to kind of run through a typical fault process. It's probably going to be a bit more of a group therapy session than than anything else. It's based on a real fault that happened to us. And it always starts with a problem from an end user. Bernie Sanders is not trying to sell us transit anymore. He's complaining about his in-game ping. And you might not know this about Bernie, but he's actually somewhat of a power user as well. So he sent us a screenshot of a trace route. The trace route is not even on our own network. This is the famous Star Wars trace route, which is also, I think, sadly no longer with us. And before you know it, it's made it into your help desk, who have acknowledged the fault. And your in-game ping is very important to us. Please hold the line. And then eventually it lands on one of our desks, and we're logging into routers wondering, okay, in-game ping sounds important, and we're running all kinds of commands. We're pinging things 100,000 times, and we're running all the usual commands. One thing I'd like to point out is that at some point in time, someone in your organization would have come up with a router naming scheme. It's probably router and a number, maybe an airport code and a number. By the time you're in the 27th pop in the same airport code, you're kind of wishing you probably chose a different scheme. The prompt feature is pretty underrated, and this is inside of an Arista router. You can customize the prompt to say whatever you like. So in my case, I've got the original thing, and I've augmented it with a rack number and the data center. So when I'm switching between windows, I don't accidentally confuse myself. And of course, we're jumping on our old pals and looking glasses. And we're doing all kinds of reverse trace routes and all that kind of thing. We're then going to jump into our monitoring. We're going to go, yep, all looks good. Can't see a kind of sudden drop in traffic or anything like that. And we all do it. Is anyone else complaining? If it's isolated to one user, well, it might not be real. And so we fire back to the customer and we go, mate, I can't reproduce it. I'm going to need a bit more information. And eventually, customers are persistent. So they're like, no. Like every time I die, my ping is super high. It's definitely a problem with the network. And we go, okay, it's an intermittent fault. And finally, we can actually reproduce it. We've transported ourselves back to classic iOS to do a ping, and we can see some packet loss. It's also a live stream of the cust data power source, which sadly had a bit of a nap, but we're back on track. And before you know it, you go, okay, it's actually not a fault in my network. It's a fault in someone else's network. And you find yourself in a portal these days. This is the Optus portal. This was actually a fault involving Optus. And they're great. The key feature of portals is that you both agree what service you're actually logging the fault on. And by the time you get to the portal, at this point, it's a packet loss fault. It's completely forgotten everything about the service that you selected at the start. It's asking us if we have rebooted the NTU on our Ethernet over DWDM service. It's also asking us some questions that we're sort of scared to answer, like, do you provide special services? And it's asking all of the things like, reverse trace route pings. It's one of the better forms I've ever seen. And so you fill it all out, and you're like, man, I have done my job. I have given them everything that they need to fix this fault. And before you know it, it's inside the machine. And I didn't realize this worked back in the 90s when I was playing this game, but it is actually in Optus's color scheme. And it kind of goes, it goes through the machine. And cool, someone jumps on it pretty quickly. They acknowledge the fault, and you're notified that someone has actually looked at your fault. And then you get this. PE interface is up. I've sent 1,000 pings to Google's DNS. Can't see a problem. And at first you're kind of going, man, are we looking at the same fault? And then you actually realize that this is probably the network engineer's equivalent of the middle finger, and that the help desk at Optus know that this is not their problem. And as I scroll down the ticket, I go, okay, we've checked the DWDM, and the receive power is actually -18. And I'm no optical genius, but that's a pretty bad number, particularly when it's an optic inside a data center. And so we go into the data center and put our light meter on it. Yep, the optic is not transmitting much power, and we replace it and everything's fine. Packet loss is gone. And so after these sorts of events, you look at your monitoring and you go, man, what am I not doing that could have told me? You look at optical temperature, you look at the transmit power. That's the transmit power, I think, graphed over more than a year. It's just never changed. These are totally genuine optics, by the way. And you kind of come to the conclusion that your monitoring is just far too inward facing, and that's okay. Like we're not expected to kind of monitor the entire internet. We're really only concerned with the stuff inside our own networks. And so I come to the conclusion that we just need to kind of ping all the things. Had we been perhaps pinging the Nexthop address on the Optus side, or something inside Optus a bit more aggressively, maybe we would have actually found the packet loss. And our networking monitoring system is probably like yours. It might be boxes in a couple of data centers. You might have some probes out there, and ultimately it catches what it catches, but it's not perfect, and it's largely inward facing. And we kind of decide, look, we have more routers than we do servers. We're not a server company. We're a networking company. And so we want to actually just look at our routers and just kind of see if there's any easy wins and stuff we can turn on. And so we kind of look at the documentation and go, well, we're using Arista. They've got this feature called Connectivity Monitor, and its prime purpose is to ping stuff. And it can also measure latency of TCP three-way handshakes. It's got a lot of features built in. And you kind of tell that over time the features are going to get there, and it'll be pretty good. But it's mostly there to monitor a static environment, like loop back to loop back, things like that. Report the results via streaming telemetry, and get it off the box. I ultimately decide that that's not really what I want to do. I don't really want to be having to change the config, even though our config is automated. I don't want to have to change it every time I want to ping something different. And there's things about the timing and things that I just can't customize, and I might not want to just ping things in the future. I might want to do other things. This is a graph of one of our biggest routers in the network, and it's kind of a testament to modern route engines. They're really not doing a whole lot. They have very high CPU capabilities, and they have so much RAM. Like, it's got more free RAM than my laptop has. And when it's consuming multiple full tables, you might need it, but there's definitely spare RAM and resources. In the case of Arista, I don't like marketing slides or vendors in general, but this one is refreshingly simple. You have the hardware, you have the host OS. On top of that, you have a bunch of Linux technologies that you're all familiar with, Netlink and NetFilter, BPF. And on top of that, it runs a bunch of applications. And in the case of them, they actually allow you to run containers directly on the route engine of your routers. And they must have some customers who are doing some fantastically complex things with that. And so you kind of step into the unknown. You don't have a whole lot of reasons to go into the shell on a router. It's totally possible to live your life just interacting with the config and all that kind of thing. And when you look under the hood, it's actually running Linux. And you kind of know that in the same way that your toaster runs Linux and your doorbell runs Linux. But it's not real Linux, and you're probably not really meant to play with it. But this is real Linux. And in this case, this particular one is Alma Linux 9.4. If you log into a slightly older, it'll say CentOS 7. I personally have not used an RPM-based distribution in a long time, so I had to dust off some skills, mostly Debian-based. And the further you look under the hood, it is just normal Linux networking. In fact, the VRFs are Linux namespaces. The interfaces that are in your config as Ethernet, 23/1 or whatever, are actually ET23_1. And so we set up a bit of a test. And the test is a couple of 7280s, and we link them together by 100 gig ports in the office. And we go, okay, we've got all this Linux stuff, got all this compute power, and some RAM. What can we actually do with all this? And you straight away go, well, how fast can it go from the route engine? And Arista has got a copy of iPerf into their base image, and you try to run it for the first time, and it says connection refused. So big quick Googling, okay, it's all based on IP tables, no worries, let's add some rules. And before you know it, you're doing 237 megabits per second between the route engines of two routers. Considering it's just a route engine, it kind of makes sense. And then you go, well, the numbers are just too round, and the number is just kind of too small. So let's disable all the safeguards. Let's start by clearing the IP tables rules and see if there's any kind of packet rate limiters or protocol rate limiters. And you get much the same results. And then you kind of go, well, it's probably the hardware protecting the control plane. Thankfully, the vendor allows you to customize it, and they allow you to completely turn it off. And so you rerun the test. This is not financial advice, guys. So you rerun the test, and you get a perfect number, 1.21 gigawatts. And you're like, okay, that's a great number. I'm just planning to ping some stuff, so I don't really need that much bandwidth, but I'm sure some cool people are doing cool things with that. And then there's something else you do in the CLI of your router when you run a trace route is you're generally asking the router to do a best path trace route. You might specify the source IP to get the source interface to get the source IP, and it'll take its path through the network. But what you can also do is set the source IP to a source IP on a particular interface and then force that traffic out a particular interface. It's ignoring the installed routing table. At the top, it's going across my own network, across to, I think, this is hetzner.de's website. We're shooting it across to Perth and Singapore and on, and Telstra's probably doing something similar, but Telstra is not my best path that I've installed, but I can force the router to send the traffic out. And this is pretty useful. And if you do a process list while you're doing this, and you have to, unfortunately, probably set the count to 1,000 to catch it, it's just standard Linux trace and ping tools. And I actually verified this with a copy of strace. It's just setting socket options, it's binding to the device, it's all useful stuff. So we kind of have the elements to kind of create something that can do some pinging from the box. If we go back to our flow monitoring tool, I'd probably advise everyone to just install Akverado. That's not what we did. We actually run a separate kind of stack which gets you to roughly the same result. We're running PM-ACCT for our flow monitoring. It also has BGP sessions to all the routers to collect its own versions of the BGP table to do the route association. We're also, once again, polling it via SNMP. That's just to match the if index from the flow data to interface data. But it's also a good kind of like background check that your flow data is closely matching your actual interface data. We throw it all into Kafka to basically queue it up, and ClickHouse is just consuming it at its own rate, and we visualize it all in Grafana, and we can kind of do whatever visualizations we want. And so kind of decide to just augment the data of our flow system, and all we really want to do is add some ping agents to the flow data. And so we're going to just reuse the Kafka that we're already running, and we want to look about how we get some ping data directly from our routers into the system. There's only one real scripting language I know, and it's Python. Thankfully, it's supported by Arista. They have an SDK that they expose to multiple languages. And so we decide to write a Python daemon that we're going to run directly on the box. And this is roughly what it does. It connects to Kafka, gets a list of things to ping from a topic. We then ping them based on whatever interval and settings. We might want to go just ping this once an hour, ping it once a second. And as part of the data, we're going to send back the router ID and the if index, so we don't have to waste any time, matching what interface we were pinging from and all that kind of thing. One of the challenges you'll find back with the previous about namespaces, if you're doing anything with VRFs, even your management VRF, you're going to have to basically take care of where your sockets are created. Particularly if you're, say, pinging in the default VRF, but you want to send the telemetry over the management VRF. You're on your own there, and you have to basically handle it in your code. You can also install any RPM you want because it is just standard Linux, and that's the greatest feature. I think it's unlocked a new job interview question, which is get a copy of Chrome running on this Arista switch, and because it is a flash-based system, you have to be very careful about what survives a reboot. So everything has to be put into the boot extensions and that kind of thing. And essentially, you end up in the config and you create a daemon. You can call it whatever you like, and you're just telling it to execute something. And it can be a bash script running a while loop or whatever. It's not picky about what it is. You can use the SDKs or you don't have to use the SDKs. And you can either pass in command line arguments or you can subscribe to the option events. And it's an event-based system. It can subscribe to interface events, all kinds of things. But one of the things is config. If you want to change the config of your running daemon, you can. And you also get a bunch of other things for free, which is the process manager, which will launch it for you. If it crashes, it will relaunch it with sensible backoff. And you also get free logging. You can also set status variables as part of your running program, so it can tell you, how many things it's pinging or whatever you want. And those variables will actually survive the process being restarted. They're stored somewhere else. And so we kind of get to all of this, and we have this system that can ping stuff, and it can ping stuff based on things that we tell it, and it's linked to the flow system. And so where your mind probably goes is you go, okay, we should probably start looking at like the high traffic flows. Where are we doing most of our traffic to? Let's try pinging that and get some measurements. But that's not what I did. I decided that I'm going to ping the top 2,000 things that other people are already pinging. And so you go into your flow system and you go, all right, I want it to limit it by ICMP. And you go, man, is this even working? Like, that number is so small. And so you start looking at the top pinged hosts, and to the shock of no one, it's these two. Every SD-WAN vendor on the planet thinks that the internet is down every time these guys have a hiccup. And if you ping them rapidly enough, you can get your own smoke ping style, jitter smoke and all that kind of thing. And I actually looked at my traffic to Google's DNS. 10% of all of my traffic to that is actually ping. It's not DNS at all. And because it's all linked into your AS system, you can actually just go, well, what are people pinging? And one of the things we do is connect into Telstra and Optus, and people seem to like pinging stuff in there, and the wider internet in general. And so you can collate all of this data, and again, you have no idea what people are pinging. You don't know what's on the other end of that connection. Is the data useful? No one knows. But we have the data, and we're hoping to perhaps we're hoping to kind of get some extra data on our network that we didn't already have. And so because it's all in Grafana, we can kind of just start making any dashboard we want based on the top 2,000 things that we're pinging across the internet. We're going to give ourselves a network health score, which is completely meaningless. And we start to identify what our average latency is across the entire network. That's a pretty useful stat. And it turns out that the top 2,000 things that our customers or ourselves are pinging are based in 191 AS numbers. And based on that, you can track the changes in whatever it is you're monitoring. And the idea with the system is not to kind of run it all the time. Maybe it's more sort of targeted based on customer faults and things like that. You could also get jitter per AS number, and this is probably more useful. It's about tracking perhaps the changes, not so much the actual values. And we also get the packet loss per AS number, which again is somewhat questionable, but if it was an AS like Google, I'd probably trust it more. If it's an AS, off on the far internet, then it's probably far less useful. That's my talk. Thank you.